Sorry, it wasn't recording. So rates of reactions. In reactions we have reactants going to products, and a rate can be determined by the change in the amount of the products over time, or the change in the amount of the reactants over time. So either or, both of these equations can be used. Now, how do we get the amount of reactants or the amount of products? We can use mass, or we could use mole, or, sorry?
Molar mass.
Or volume.
Molar mass.
Volume, we could use volume, yes. Not molar mass. What else can we use? Yes, you're right. We could use these things. To measure amounts, we can use these things. Now, there will be a change in the mass of a reaction mixture when?
After the reaction.
What type of reaction will have a change in mass?
And change in mass.
Yes.
Addition, breaking apart.
Yeah.
Remember we said mass is conserved.
Yes,
So the total mass of the reactants would be equal to the total mass of the product. But we do get reactions where gases form. So if I want to measure the change in mass, the change in the amount, okay, what can I measure? I can use, for example, if hydrochloric acid reacts with sodium carbonate, what will be the products? It will be sodium chloride and water and carbon dioxide. And this carbon dioxide is a gas that can escape the system. So I can use the change in mass of the reaction mixture to measure how fast the reaction is taking place. Because I can measure like in second intervals or 2-second intervals, or maybe the reaction is very slow and measure the mass, the change in mass every minute. But usually time is measured in seconds. So when a gas is formed, there will be a change in the mass of the reaction mixture, the amount of reactants. Or I can measure the amount of gas forming. So I can measure the volume of the gas forming. So we can measure the volume of the gas as it forms per unit time. So I can measure the change in the mass of this stuff. There will be a change in the mass of the stuff. Or I can measure the change in the volume of the carbon dioxide that is formed. Okay? We could also use a change in moles, because as the reactants are used up, there will be a change in mole. So we could have a change in mole. There will definitely be a change in concentration. Usually your hydrochloric acid has a specific concentration. So you can measure the change in the concentration of the acid in a specific time intervals. Good. So are you with me?
Yes.
Good. How do we calculate moles? Now, you can talk your molar mass story. can you remember how to calculate moles?
Yes.
You can calculate, you can take mass and divide it by molar mass. Yes. What else can you use? If you've got gases, you can use moles equals volume over molar volume. Okay? Somebody said C?
C equals to N over.
Okay, so C is for concentration is equal to moles over volume. That's what we use for concentration. And what if they tell you, if they're really nasty and they take you back to grade 10 and 11 and they tell you how many particles there are, how will you be able to get moles? Yes, so it's the number of particles. I see on the data sheet for the grade 11s, it's a capital N divided by the Avogadro's number. Yes. So these are the ways that we can measure the amounts of things. We need to move a little bit further now. Can I wipe this or not yet?
Isn't it break?
Nearly. It's fine. At least I made a start, so I'm happy.